number 11 this time. For one test distribution, mean equals 513 and standard deviation equals 91. And another test distribution, mean is 15 and standard deviation is 5. Maybe the SAT and ACT, something like that. But when you take these two different entrance tests, the tests, the scorings are just all different. Like I know for SAT, they go up to 1400 or 2100 now, and ACT only go up to like 30. I have no idea now, but they're looking extremely different. You're not gonna compare somebody's 28 on ACT and say, oh, it's so low compared to my 540 on my SAT. So if you want to compare these two different standardized test scores, or in this case, we got two different tests here. What should we use? We need to standardize these scores so that we can actually compare them, right? Say that which score is relatively higher, a score of 510 on first test or a score of 22 on the second test. Explain. Let's find the z-score of both. Alrighty, on my little notepad, I've been taking notes from my other problems. I'm going to go ahead and type in the z-score formula. Remember, z-score equals, this looks like a z minus score, z-score equals x minus the mean, the actual value that you get, minus the mean, and then you're going to divide that by the standard deviation of the distribution, right? Ta-da! That's what you're going to do. You're going to do this, so let's go ahead and find the z-score for the first test. Okay. The z-score for the first test, this person made what? This person made 510 on the first test. The mean of that test was 513. He did worse than the mean. So we're going to get a negative z-score. The standard deviation is 91. Let me get my tiny little calculator. Not Safari. Calculator. Alright, let me close my Safari. What are you doing here? Alright, so let's do 510 minus 513. I hit enter. Negative 3. And I'm going to divide that by 91. The z-score came out to be this number. I don't think I can copy this. Negative 0.03. Negative 0.033. I'll just round it that much. So that's the z-score for the first test. Let's find the z-score for the second test now, okay? I'm just gonna z-score for the second test. Alright, let's see. This person made what score on the second test? He made 22 on the second test. And then the mean of that test was what? 15. I don't even have to do this. Because you notice? He did better than the mean test score for the second. In this z-score, if you do 22 minus 15, we're going to get a positive z-score. But let's just keep going. What's the z-score for this one? 22 minus 15. And then you're going to divide that 7 by 5. The z-score came out to be 1.4. So for the second test, he did 1.4 standard deviation above the average. And for the first test, he did lower than the average. So of course, which test did he do better? The second test. The second score is relatively higher than the first score because the z-score on the first test is less than the z-score on the first test score on the second test. I think we should probably read it carefully, but the main idea for this problem is just simply calculating the z-scores and going with the one that has the higher z-score. Read them carefully, but that's the main idea of this problem, alright?